Today we're going to be doing the 2020 AMC 10A problem number 17. The problem reads, define px equals x minus 1 squared times x minus 2 squared all the way to x minus 100 squared. How many integers n are there such that pn is less than or equal to 0? First, what we're going to do is we're going to divide this problem into cases. The first case, case 1, would be if Pn is equal to 0. In order to make Pn equal to 0, n could be 1 or 4 or 9 or 10,000. So, for example, since Px is equal to x minus 1 squared times x minus 2 squared all the way to x minus 100 squared, then if, for example, x was equal to 1, then when we plug this in, this right here would be equal to 0, which would make the rest of the product just equal to 0. Another example would be 4. So 4 minus 4 is equal to 0, and so that would make the entire thing 0 as well. Another example could be 10,000. If we plug that in here, 10,000 minus 10,000 makes the entire thing 0. So that would mean that there are 1, 2, 3, 4, 5, 6, all the way to 100 integers that make Pn equal to 0. There are 100 integers that result from Pn being 0, or case 1. Now moving on to case 2, which is Pn is less than 0. I'm just going to experiment here and see what I can come up with. So I'm just going to get a random number. If x is equal to 2, then this would be 2 minus 1 squared, 2 minus 2 squared, all the way to 2 minus 100 squared. Now that would make this equal to 1, and that's positive. This would be negative, because 2 minus 4 is negative 2. All of these would be negative, and this would also be negative. So that means that there's 1 positive and 99 negative. Now remember that 2 negatives is equal to 1 positive. So for example, negative 2 times negative 2, 2 negatives is equal to 1 positive. So that means here this would equal a negative. I'm going to experiment some more. Let's say x is equal to, let's say it's 5. Then if we plug that in, we would get 5 minus 1 squared, 5 minus 2 squared, 5 minus 3 squared, all the way to 5 minus 100 squared. And so this would be positive, this would be positive, 5 minus 9, that's negative, these would all be negative as well. And so that would mean there's 2 positives, and there's 98 negatives. This would be positive. Now if you experiment some more, you'll start to see that a pattern emerges. I'm going to rewrite what the problem says. So now we can find how many integers there are so that Pn is less than 0. If x is between 1 and 2, then there will be only 1 positive, which means that there will be 99 negative, because the rest are negative. And so that means that the entire product is negative. Now if x is between 2 and 3, then there will be, as shown here, or 1 squared and 2 squared, 2 squared and 3 squared. Then as shown here, there's going to be 2 positives, which means there are 98 negative, which means that the entire product is positive. Now if we do this one more time, if x is between 3 and 4, 3 squared and 4 squared, then there will be 3 positive, which means that there will be 97 negative, which makes the entire product negative. And so if we keep doing that, we'll see an alternating pattern of negative, positive, negative, positive, negative, positive. Now we know which values of x make Pn less than 0 or negative. Now we need to find out how many of those integers there are. So 1 is less than, or x is between 1 and 4. That means x could be 2 or 3, which means that there are 2 integers. Now the next one, x is between 9 and 16. Then x could be 10, 11, 12, 13, 14, or 15. And that means there are 1, 2, 3, 4, 5, 6 integers. Let's just do another one. X is between 25 and 36, or 5 squared and 6 squared. Then x could be 26 through 35, and there are 10 integers. Now let's do the very last one. So I see that if x is between 1 squared and 2 squared, 3 squared and 4 squared, 5 squared and 6 squared, then it would be 99 squared and 100, or 97 and 98. So if x is between 99 squared and 100 squared, then the entire product will be negative. 99 squared is 9,801. And then 100 squared is 10,000. So x could be 9,802 through 9,999, which means that there would be 198 integers. So now we'll see a pattern emerging where there are 2 integers, 6 integers, 10 integers. If we add this all up, then we'll get how many integers and there are for Pn to be less than 0. And so we see a pattern that these are increasing by 4. So 2 plus 4 equals 6, 6 plus 4 equals 10, and then so we assume that the next number of integers there are would be 14, and the next one and the one before this would be 194. In order to find the sum of 2 plus 6 plus 10 plus 14 all the way to 194 plus 198, we see that if we add each of these, the first and the last, and then the second and the second to last, then we get the same thing over and over. 198 plus 2 is equal to 200. 6 plus 194 is equal to 200. And so this would be the case for all of these in the middle. The sum would be 200 times the number of numbers in this list divided by 2. And so in order to find out how many numbers are on this list, we can look back to here. There are 100 of these numbers in parentheses here. We took pairs of each, so that means that there are now 50. So the number of numbers in this list is equal to 50. And so this entire thing is equal to 200 times 50 over 2, which is equal to 200 times 25. And so that is equal to 5,000. So 5,000 plus 100 is equal to 5,100. And if you look at the answer choices, that is answer choice E.